All right, so let's take a look at our lesson for today. So far for our integration, we've just really been looking at formulas and going backwards, right? We haven't really encountered any yet that aren't just a pure formula. And so I'm just going to remind you, like we worked last time, with the definite integral where we knew what the antiderivative of force sine was. It's like a formula. And so we were able to just go straight from, this, remember, is the integrand right into the formula. What we're going to look at today are some examples that, and actually, most of the time, this is what we're going to deal with. Most of the time, they're not going to be straight formulas that we can go into. Most of the time, they're going to be integration using substitution. And the shortened, we just call this U sub, or U substitution. So probably, let's work through it for just a moment. I want to look at this formula and talk about the formula. So this is how U substitution works. We'll have a function f, and there'll be another. So remember composite functions where we have one function embedded in another. So in this case, we would have, like this function is embedded inside of f. And so in the integrand, just going to remind you, this part right here is called the integrand. In the integrand, we would have a function with g inserted into it and a multiplication. This is always multiplying, not added. Multiplied by the derivative of g. So that's the pattern that we're looking for in the integrand for us to set up this U substitution. So one function embedded in another, and its derivative, the function who's embedded, g's derivative exists in the integrand. When we have that scenario, what we can do is we can make the substitution, again called U substitution, and it turns into a much easier problem to integrate. Much easier. That's the purpose of U substitution, is turning something into an integrand you can actually integrate. So these are the steps. And these are just kind of general steps. We're going to go through several examples to hopefully help. So first, we're going to look for some composite function, something f of g of x, for that we can set u to be g of x, and then our du would be g prime of x dx. Okay, and so we may not pick the correct u the first time, and that's okay. That's why if, we might need to try a different u. And it's okay if you don't pick the correct u the first time. That's okay. Okay, so that probably makes no sense to you right now, so I'm going to go straight to this thinking process. What we're going to do is we're going to look at these, and we're going to try to decide what would we make u, and what would the derivative be? All right, so the first one, this is so close to a formula. This one right here, so close to a formula. What is the problem? Does the formula have a 7 in it? No, the formula doesn't have a 7 in it. That means we can't do it by just the formula. We have to do a U substitution. So what's happening here is this function is embedded inside this one. So for this one, our u would be 7x. Once we designate what u is, then we take the derivative of it. So the u would become du equals the derivative of 7x is 7, and then we have dx. Okay, and we're going to go through a whole process in a moment. We're just right now, we're just breaking the surface. We're figuring out what's u and what's du. Okay, so I'm going to pause here for a second. So what we discovered was 7x was the embedded function. And when we're doing this, sometimes students find it helpful to write the functions down. You remember like we did when we were doing derivatives and we had chain rule? Remember how we used to write the functions down, like f was this function and g and so forth? Sometimes students find it helpful to do that. You can if you want. The outside function here was sine of x. And the inside function here was 7x. If that's helpful to you, you can certainly do that. It's not required, but this is giving you a picture. This is a picture of how we decide what is the outside function and what is the inside function. Okay, are we all right so far? Okay, so let's look at our next one. We want to figure out what's u. And let me just say, let's do some guidelines out here. Where do we usually find u? Let's make a list. Okay, I'll just write it up here. So, where do we usually find u? This is important for us because this is going to help us decide. This is probably the hardest part of u substitution, is figuring out where u is. Okay, so where do we usually find u? U is usually, well, it's inside. So let's say it's like under a radical. So here's one example. Under a radical, we usually find u under radicals. We find them in the exponent. We usually find them there. And the third place we usually find them is in the denominator. I'm just telling you the most likely places they're going to be. That's all. These are the most likely places that we would find u. We would find it under a radical, in an exponent, or in the denominator. Okay. That's normally where we would find it. That's like 90% of the time, that's where it's going to be. Okay, so questions about that so far? That's where we would usually find u. When you're looking for it, these are the places to look. All right, so let's look at our next one. So this one is more complicated. So what I'm doing when I'm looking for u, y'all are like, what? I'm looking for the derivative to exist outside of the, u. So here in this case, the derivative is 7, and I don't want to hurt 7's feelings, but we really aren't that concerned with constants. Okay, we have something else we can do with constants. So I'm just going to write a little note out here. Constants are not concerning. In other words, we don't have to, a 7 does not have to be right here. We don't need a 7 in there. Okay, they're not an issue. We deal with constants in other ways. Variables are an issue. Variables are a big deal, but constants are not an issue. We don't have to have the 7 sitting here. We have another way to deal with numbers. Okay, so let's look at our next. With that in mind, let's look at this next one. So what I'm wanting, so I'm thinking to myself, this stuff under the radical is probably u. That's probably u. So let's write that out. U is 7x squared plus 12. Du, I'm taking the derivative of that. That would be what? 14x dx. So what as my goal to find u, I need the du to exist. The 14 we don't really care about. But this x, see, it's right there. If this x were not right there, we could not do this. I need to be real clear. We could not do this if that x were not there. The 14 we don't really care about. We're going to deal with the 14 a different way. But the variable has to exist. It has to exist outside of the u by multiplied to the u. Okay, are we okay so far? So why did I pick the stuff under the radical? Because, that's usually where it is. I listed you the places where we usually find u. That's one of the normal places. I do set it to u. I find the derivative, and I verify that the variable in the derivative exists in the integrand. Okay? We good?
It has to be multiplied by u?
It has to be multiplied. It has to be multiplied. The du has to multiply to the u. It can't be added. Like if that was x plus that, we're done. We can't do that. Now that brings something to mind. So it was possible for us to find any derivative we want. Remember that? We had rules for everything. Integrals are not that way. There are some integrals we cannot do by hand. It's impossible. Okay, it's impossible to do by hand. So if U sub doesn't work, well, there are a lot of other techniques that we learn in calculus 2, but in calculus 1, we pretty much stick with U sub. Okay, so let's look at the third one. So I said most likely we find things, the three places we find U are under the radical, in the exponent, in the denominator. Those are the most likely places. So let's look at this one. It's probably in the denominator. Let's check to see if it works. It's probably in the denominator. That's probably it. So let's say U is 4 minus 5x squared. D would be negative 10x dx. Okay, so what do I have to do? I have to make sure that any variable that occurs in du is actually in the integrand. This is the step that sometimes students just gloss over and they don't think about. I promise you, if it's not there, then you're not going to be able to do it. So I'm looking here. I see this is a variable. This we're concerned with, and we see that it exists right there, so we're good. We're good. We picked the correct u. Okay, are we okay? All right, let's look at number 4. Okay, so according to those locations that we talked about, what do you think u is?
Sine.
Sine. U is sine. It's right here. Okay, so u is sine x. The derivative of sine is cosine x dx. We need to make sure that this function exists right beside as a multiplier, and it sure does. So we picked correctly. If it doesn't, then we picked incorrectly. Okay, are we okay? All right, so let's go to the last one is the weirdest one, of course, right? So here's what we normally would do. We would normally say, oh, well, u is what's in the denominator. So let's try that. Okay, so let's see, u is 1 plus 16x squared. Du would be, is that 32x dx? Do I have this x anywhere? Nope. I picked incorrectly. That is not correct. I'm going to pause here for a second. Do we see why that's not correct? If I had an x up here, I'd be good to go. We'd keep going. But I do not. So that was incorrect. I want to make sure we're okay on that first point. Do we see why that's not correct? Okay. So now what we have to do is we think, well, okay, this must be really close to a derivative that I know. Really close. Do we recognize, is this really close to a formula that we have memorized? It is, isn't it? What's the formula? It's arctangent, right? It's really, really close. So I'm going to, right over here on the side, I'm going to write what arctangent looks like, and I'm going to try to match and see what u is going to be. So this is what? It's 1 plus, it's usually like that, right? 1 plus x squared. That's arctangent. So my problem is the 16. So what I need is, this is what I need. I need it to look like 1 over 1 plus something squared. That's what I need it to look like. I need it to look like so that I can match. This has to match, look like that, right? That's what I'm looking for. So I need to think, what could I square and get 16x squared? What could I square and get 16x squared? 4x. I could do that, 4x. So what's happening here is u is going to be 4x and du is going to be 4 dx. Okay, this is a very strange one. That's why I put this up here. I want to make sure we see how they're, like I said, 90% of the time it's going to be in one of those 3 locations. But sometimes it's going to be like this. Weird.
I thought that you have to have like whatever you're looking for in the equation.
You do, except for a constant, except for a number.
Okay.
This number is not necessary, and I hate to hurt their feelings because they're not important, but they're important, but they don't need to exist in there. And I'm going to show you when we start working a problem, I'm going to show you how we fix that. There's a fix to that because that's really normal. Normally we are going to have a number there that isn't in the equation at all or the integrand at all. All right, are we okay? We good? So now I hope that's the hardest part is figuring out what u is. So now we've got a really good feel, I hope, for what u is. Now let's work a problem. Okay? So let's go here. Let's look at this one. Okay. Now, if I didn't want to do u sub, I could take 3x minus 5 and multiply it out 5 times. Does that sound good? No. I mean, I would have to do like 3x minus 5 times 3x minus 5 times 3x minus 5 times you see what I'm saying? That would be like really painful. Do we really want to do that? I mean, no, we don't, right? We don't. So that's why u sub is a wonderful thing. So I don't have a radical, but I do have this going on. I have this part right here that's embedded. It's embedded in something. Okay, so if we were doing chain rule, which we're not, if we were doing chain rule, our f, remember from chain rule, what would f be? Like x to the 5th, right? Remember from chain rule from a long time ago? I'm just talking about composite functions, and g would be the inside stuff, right? That's what it would be from when we were doing chain rule from composite function days. So let's set our u up. So u is 3x minus 5, du is 3 dx. Now, I'm going to highlight. This is going to be that. So this is what we do with the constants to get them out of the way. What we do is we move it to the, so we divide both sides by 3. So I have 1/3 du equals dx. That's what we do. That's what we do with the constants. We move it over. And we basically ignore the middle, this middle, line we don't pay attention to, which is these two. So what I'm going to do is I'm going to highlight. So what we're substituting, where the yellow is, I am going to put a u in that place. So I'm going to put a, this is going to go into where the 3x minus 5 is. That u is going to replace it. And likewise, I have to replace the dx. This dx is coming out. And in its place is going to be this right here. Why? So the issue with us is the integral can only have one variable in it for us in single variable calculus. All right, so see, I have x's and dx in my problem. All right, when I rewrite this, I am only allowed to have u's and du. I am not allowed to have a dx. That is really important. Okay, we have to completely change the variable over. So now what I'm going to do is I'm going to rewrite this problem with the things I've boxed in pink. The other stuff is coming out. Everything I highlighted is coming out. And the things that are going in, so you can also look at it this way. So this side, if you will, this side these are coming out and these are going in. That's pretty much how it works. The right side, all that stuff's coming out, and the left side's going in. All right, so let's do that. Let's make our replacements. So in place of the yellow, I'm putting a u, and I have u to the 5th. In place of the dx, I'm putting 1/3 du. Now, I prefer to have constants outside of my integral. That's my preference. So I'm going to move it out. 1/3 integral u to the 5 du. And I'm going to pause here for a second. We have completely changed the way it looks. And now it's a formula that we know and we're going to be able to do easily. Questions so far? All right, so now I do my reversal power rule. Let's see, I've got u to the 5th. I add 1 to 5, and I get 6. And I divide by 6, so I have 1/3 times 1/6 u to the 6 plus c. My very last step is to put the u back in. That's something that students forget sometimes. You have to put the u back in. You have to, otherwise you haven't finished. Just like when we put the plus c, remember that? If we don't put plus c, we haven't finished. Well, if you don't put the u back in, you haven't finished. So u was 3x minus 5. So my final answer is 1/18 3x minus 5 to the 6 plus c. And that's our very first full u sub. How are we doing? I think the more we do, the easier it will get, I promise. The more we do, the easier it will get. And maybe this is really easy for you, and y'all are like, why are you going so slow? But really, sometimes students have a really hard time with u sub, so I'm trying to make sure we understand every step. Are we good? Okay, let's do our next one. Now, let's add something to our list up here on where's the most likely places to find. Let's do number 4, inside parentheses. And I'm going to spell parentheses wrong. I'm sorry. Did I spell parentheses wrong? Is there an E on it or something? Is that right? Okay. So that's the 4th place. So I'm trying to give you the most common places to look. Under the radical, in an exponent, in the denominator, inside parentheses. Okay. So let's look at our next problem. Now, typically, we would be in the denominator, but my question to you would be, if I took the derivative of the square root of x, would I get the square root of x minus 1? Would I get that? No, I wouldn't. I wouldn't. So this time, it's in the parentheses. It's here. This is u in the parentheses. Okay? So let's write that out. So we have u is the square root of x minus 1 du. So let's see. So remember, this is x to the 1/2. So this would be 1/2 x to the negative 1/2 dx. Okay. I don't have a 1/2 in there, so I need to move the number over. Moving it over, so that's 2 du equals, and I'm going to rewrite it like this so we can look at it. All right. Okay, so there's my u. Now, in this integrand, see how we have a square root of x on the bottom in the denominator? Looking at this, isn't that where it's supposed to be? Right? It's supposed to be in the denominator, so this works perfectly. If it weren't, we would have a problem. But it's in the denominator. This works perfectly. So this right here replaces, like there, think of there's a 1 here. It replaces that. Okay, and then this is going to go in, and this is going to go in. Okay, remember, if you want to, you can think of it this way. This comes out, and this goes in. Of course, you know, we ignore the middle line because that was just the derivative line. We got to clean it up. Are we okay? So basically, everything I have highlighted in that integrand is going to disappear, and something's going to take its place. Is the squared going to disappear? No, it's going to still be there. But everything that I've highlighted is going to leave. And it's going to be replaced with the stuff that I have here over on the right. So the 2, I really prefer to put outside the integral. I just prefer numbers on the outside. We've got u squared du. Doesn't that look so much nicer and cleaner than what we started with? That's going to be so much easier to work with. Is everybody okay on the rewrite? All right, so now I just do my regular reversal power rule. So let's see, I add 1 to 2, which is 3. So I've got, let's see, I'm dividing by 3. So 1/3 u cubed plus c. Am I done? Am I done? No, I am not done. I have to put the u back in. So I'm going to rewrite that. So that's what, 2/3. And then what do we have? We've got the square root of x minus 1 cubed plus c. Okay, how are we doing? We getting the hang of this u sub business? I have 2 more examples. Questions? Okay. Let's go. We've got 2 more examples. Let's work this one. Okay, knowing where we usually find u, what do we think u is going to be here? It's going to be cosine. That's my u, so let's write that out. So u equals cosine x du equals derivative of cosine is negative sine x dx. Okay, I don't have a negative in my integrand, so I'm going to move it over. So negative du equals sine x dx. All right. So let's see. So we've got, here's the cosine business. That's going to be replaced by u. I've got my sine here, which is this and this. That's coming out. The things I've highlighted are coming out, right? And it's going to be replaced by negative du. So when I go and put stuff in, what I have in the integrand right now, is e going to still be there? Yes, it's still going to be there. Okay, all the rest of the stuff's going to be gone, but e is still going to be there. So let's do our substitution. Again, I like to put the constant outside the integral. That's just my preference. You don't have to. E to the u du. And that's way easier. Isn't this u sub so nice? I mean, what's the antiderivative of e to the u? E to the u. See, that's so nice. So negative e to the u plus c. Am I done? No, I need to put the u back in. So my final answer is negative e to the cosine x plus c.
Wait, how did the sine x go?
Since the derivative was sine, it came out.
And then c just replaces du?
The c just replaces, yeah, it replaces the du, if you will. Yes, the du is gone because we've done the integration, and the c takes place of our poor little constant that we don't know what it is.
Can you go back up to 7?
Sure. Is everybody okay with 8? Can I move back real quick? Yes, we're good? Okay. Any questions on that one?
Okay, I'm good.
We good? Okay. All right, are we good on 8? Does everybody understand where everything went? Okay, last one is, okay, it's the hardest one. So let's look at it. Okay, so first off, we notice there's a 3x there. That's not okay. But the thing that, okay, so u could be 3x. That is true. But is cotangent the derivative of something that we know? Is it? Is it the derivative of something we know? No, think of all the derivatives. Derivative of sine, cosine, derivative of secant, derivative of cosecant, derivative of tangent, derivative of cotangent. Is any of their derivatives cotangent? No. No. So we have a bigger issue than just u sub with this trig. We're going to have to rewrite it using an identity. We're going to have to rewrite it. So what cotangent, there's a couple different ways to rewrite it, right? We could write it as 1 over tangent, but that's not going to help us. Is 1 over tangent the derivative of anything? No. What is the other way that we can rewrite cotangent? Cosine over sine. That's what we're going to have to do. We're going to have to rewrite it as cosine over sine. Okay, so yes, sometimes we're going to have to do a rewrite before we can do the u sub. So this is cosine 3x over sine 3x dx. Now, it seems like we get to pick whichever one we want to be u. That's what it seems like. We could pick sine or cosine to be u, but that is not correct. Okay, according to the 4 locations where we normally find things, where should we look? In the denominator. But I want to show you why you can't make u cosine. What is the derivative of cosine? Negative sine. Is this really sine? It's 1 over sine. What's 1 over sine? Cosecant. So I can't make u cosine. I'm going to say that again because this sometimes escapes us. So the derivative has to exist perfectly if, and I'll just write it out and then I'll erase it, if I made u cosine 3x, du would be negative 3 sine 3x. And this is not sine. This is 1 over sine. That's not okay. Are you with me? I know sine is in the denominator. I get that, but that's not really sine. That's 1 over sine. So this is not possible. We cannot do that. All right, so our only choice is to go to the denominator like we talked about before. So u is going to be sine 3x. du, derivative of sine, well, we have to chain it, would be 3 cosine 3x dx. Do I have a random 3 anywhere in that integrand? No, I'm going to have to move it over. 1/3 du equals cosine 3x dx. Now I'm going to do the highlighting, so just so that makes it clearer. So this was our u. Okay, we're going to replace that in the bottom right there with the u. We've got this part right here is going to go away, and it's going to leave us with this. Virtually everything in there is going to disappear except the fraction bar, right? And if you want to do the little, this side comes out and this side goes in, you certainly can if that helps you remember what's going on. Okay? All right, are we okay? All right, so let's rewrite it with the proper things in it. All right, so the integral, so I've got a 1/3 outside. I like to put them outside. The top, that's going to be blank, so I need to put a 1 there. Right, there's going to be nothing left up there because we took it out. The bottom, the denominator, it's got a u, and then du. Okay. So do we know what the antiderivative of 1 over u is? ln u, so we've got 1/3 ln absolute value u plus c. Am I done? I am not done. What do I have to do? Plug the u back in. So let's plug the u back in. So I've got 1/3 ln absolute value sine 3x plus c. And there we go.